everyone, it's Aria from College of Science, and today I'm joined with
Professor Jackson Kimball from the Physics Department.
And I'm just going to be asking him a few questions about the Dark Matter Lab. So firstly, what is dark matter?
Oh, that's a great question, and turns out nobody knows. It's a huge mystery, one of the biggest mysteries facing modern physics. So what we do know is there's lots of evidence of the gravitational pull of dark matter on on atoms and gas and stars that we can see. So we know that it's there from its gravitational effects. It also causes gravitational lensing, so we can see it bending light around it. And we can see that it's responsible for patterns in the light left over from the Big Bang, the cosmic microwave background radiation. And so there's a lot of evidence for its existence, and there's a lot of evidence for how much of it there is. There's about 5 times more mass in dark matter than there is in ordinary matter, but it's completely invisible. So light either doesn't interact with it at all or barely interacts with it. So we can't see it as we do with other kinds of matter that we observe in the universe using telescopes. But to figure out what it is, people have set up a bunch of experiments around the world trying to test out different hypotheses. So there's lots of different guesses about what it might be. And then from those guesses, there's predictions of what we might see in our laboratories. But so far, nobody's seen anything, so we don't know.
Oh, wow. Thank you for all that great insight. Thank you for that great insight. And could you tell me a little bit of what goes on in this lab?
Sure. So in this laboratory, we use the techniques of atomic physics. So we have gases of atoms, and we control the properties, the quantum states of the atoms in the gas using lasers, and we read out the quantum states of the atoms in the gases using lasers. So we have to have very precise and careful control of the lasers to interact with the atoms, but we also need precise and careful control of magnetic and electric fields, vibrations, things like that. And so then we build experiments that try to detect the very feeble interactions that dark matter might have with our atoms by preparing special quantum states of the atoms and then reading out how the dark matter might affect them. And so that's the idea of the experiment.
Okay, that's a lot of information. And could you tell me one thing that you find most interesting in this lab?
Well, I would say one of the most interesting things, to be honest, is the community that we've built of students and other researchers. So it turns out that our experiments are part of international collaborations. So we've built these experiments that search for dark matter, and my friends around the world on 5 different continents have built similar experiments. We all run them together simultaneously, collecting data, and then we can analyze that data to see if there's patterns, kind of global patterns induced by the dark matter or other weird physics that interacts with our atoms that we haven't yet discovered, and we search our data for that. And so it's the chance for me to work with our students to get those aha moments when they have the first experience in a research lab, but also to have our students work with researchers from all around the world and tackle sort of very difficult, unsolved problems at the frontiers of physics and have them a part of that community. That's, in some ways, probably the most exciting thing about it is the people and the friends we've made along the way.
Well, thank you so much for answering all my questions. I definitely learned a lot about the Dark Matter Lab.